Right. So suppose that I am applying a force which is nothing but F. So on the block, I am applying a force which is nothing but F. Right. Now, which tries to move the body? Under this, there is gravity, isn't it? So the gravity tries to move the body. Can you understand? So the gravity is trying to move the body downward direction. The force is pressing the body on the surface. So there produces a normal reaction N, which is equal to pressing force F, because normal reaction always tries to interlock. That means N is the force outward direction. This F is interlocking force. So this is creating N. So this tries to interlock. That means this tries to interlock. F tries to interlock. Which tries to move? Mg tries to move. Then what happens? Which tries to move? Opposite to that, friction is developed like this. This friction is equal to mu into N, which is equal to mu into N means F. So this tries to oppose. But number of cases not required. 3 to 4 cases are enough here. Case 1. First, what you have to find? Before discussing the cases, what we have to find? Limiting friction. What is limiting friction? Mu s into N. Mu s into N means F. Which tries to move? Mg tries to move. Case 1. What is case 1? First, if Mg less than Fl, which is equal to mu sf. What is friction? Here, friction is nothing but static friction, which is nothing but which tries to move Mg. So, what is frictional force? Mg is the frictional force. Simple గా ఇంతకు ముందు ఎలా చెప్పామండి, ఒక బాడీ ఉంది, ఒక బాడీ మీద లిమిటింగ్ ఫ్రిక్షన్ అంటే బాడీ మూవ్ అవ్వడానికి కావాల్సిన ఫోర్సే లిమిటింగ్ ఫ్రిక్షన్ ఫోర్స్, దట్ ఈస్ 5 newtons. If I apply a force which is less than 5 newtons, what happens? The body will be at rest. What is the friction? How much applied force? That will be developed. I told 1 newton, 1 newton, 2 newtons, 2 newtons, 3 newtons, 3 newtons, 4 newtons, 4 newtons, up to 5 newtons applied force. It should not be written as applied force, which tries to move, that will be developed as frictional force. So, frictional force which tries to move, Mg is the frictional force. This is case. Now, case 2. What is case 2? If Mg is equal to Fl, which is equal to mu sf, body ready to move. Body ready to move. Can you understand? Mg equal to Fl, that is equal to mu sf. Then the body is ready to move. When the body ready to move, what is the case? Right. Now, if Mg, okay now, if Mg is acting slightly greater than Fl, then body will be set in motion. Until you may get a doubt, sir, which tries to move, that is mg, but the mass is fixed. How I can change the force? I cannot change mg here. I can change f here. By decreasing f value, you can take that mg is greater than, mg is less than, mg is equal to myself. అంటే ఇంతకు ముందు వరకు ఏం చేస్తాం మనం అప్లైడ్ ఫోర్స్ చేంజ్ చేస్తాం. ఇంక్లైన్ ఫోర్స్ ఏం చేస్తాం ఇక్కడ వరకు నుంచి ఇంక్లినేషన్ చేంజ్ చేస్తాం. ఇంక్లైన్ ఫోర్స్ ఏం చెప్తాం కదమ్మా mg sin θ గ్రేటర్ దెన్ ఒకే ఇప్పుడు కాదు అప్ డౌన్ కలిపి మోషన్ అది వేరే. అంటే అప్ అంటే కంప్లీట్ గా మోషనే కౌంట్ అవుతుంది. ఓన్లీ స్లైడింగ్ డౌన్ స్లైడింగ్ అప్ కలిపి వేరేగా వస్తుంది. మళ్ళీ ఇంక్లైన్ వేరేగా వస్తుంది. So the body will be setting in motion. After setting into motion, what you have to think of, suppose that my applying force on the pressing force is getting changed. And 10 newtons apply chesedi, suppose I am decreasing 4 newtons. You think like that. And ala aitena cases discussion avutai. Therefore cases discussion avutai. Okay na? Now what happens? Now you can think of mg. First mg is equal to Fl. If it continues to act after setting into motion, that word same cases and then again marching oka rotating motion after setting into motion, after setting into motion, after setting to motion, what will happen? I am applying what is that mg if it is equal to mu xf, then the body will, it is already in motion, the body will accelerate. మీరు అనుకోవచ్చు ఏంటది సార్ బాడీ రెడీ టు మూవ్ అని ఇక్కడ చెప్తున్నారు, ఇక్కడ మళ్ళీ అంటున్నారంటే బాడీ మోషన్ లోకి వస్తుంది. బాడీ మోషన్ లోకి వచ్చిన తర్వాత ఆఫ్టర్ గెటింగ్ ఇన్ టు మోషన్ ఐ ఆమ్ అప్లైయింగ్ ఫోర్స్. మై ఫోర్స్ ఈస్ ఎఫ్, మై ఫోర్స్ ఈస్ ఎఫ్, బట్ దట్ ఈస్ ఆల్రెడీ ఇన్ మోషన్. అంటే ఆఫ్టర్ సెట్టింగ్ టు మోషన్, this case I am discussing. Before setting into motion, this case, the body acceleration here, 0. నేను మీకు చెప్పాను కదా బాడీని మూవ్ చేస్తున్నాండి, మూవ్ చేయడానికి ఎంత ఫోర్స్ కావాలి? 5 న్యూటన్స్. 5.001 బాడీ మూవ్ అయిపోయింది అంటే ఇప్పుడు బాడీ మోషన్ లోకి వస్తుంది. బాడీ మోషన్ లోకి వచ్చిన తర్వాత ఐ మే అప్లై లెస్ ఫోర్స్, ఐ మే అప్లై మోర్ ఫోర్స్, ఐ అప్లై ఈక్వల్ ఫోర్స్. ఐ కెన్ అప్లై ద ఫోర్స్. It may be anything. It may be anything. So what I am telling you, after setting to motion, even if I apply 5 newtons, but when it is in motion, it is encountered by kinetic friction, which is less than, which is 4 newtons. I am applying 5 newtons, just like that. Mg equal to mu s. This mg is 5. This value, it is great if it is equal, but acceleration takes place. Now acceleration is equal to which tries to move mg minus fk, kinetic friction, because it is in motion. Friction is not fs, it is fk. So when the body is at rest, conditions are different. After setting to motion, the conditions are different. Here mg I cannot change because the mass of the block is fixed. That's why I can change applied force. I can decrease the applied force, I can increase the applied force. Based on that, mg may be equal, mg may be less than, mg may be greater than. Okay, now by mass. That means mg minus fk means mu kf by mass. This is acceleration. Next, mg greater than fk. Mg is not equal to fk, less than, greater than, or opposite. Mg is not equal to fk. Then what is the acceleration? Mg again minus fk by mass only. It may be positive or negative. It doesn't matter. We need not discuss about this. Positive or negative or because fk, because we are increasing or decreasing the applied force. Calculate. So it may be equal or మీకు అవన్నీ అనవసరం. mg ఎక్కువ ఉంది అనుకోండి, mg is more, then what happens? Accelerated. If it is positive, accelerate. If it is negative, retard it. And then okay, Namai. Next, third one. Third one ఏంటి mg not equal to fk అయితే. Last one ఏంటమ్మా uniform velocity. mg equal to fk. mg equal to fk means acceleration 0 moves uniformly. Moves uniformly. So what will be this? mg is equal to fk, which is nothing but mu k into f. So mg is equal to mu k f. Then it moves uniformly. Can you understand this? Okay na ma? Cases okay na? Same cases అండి నేను ఏం చెప్పానో ఫ్రిక్షన్ అంతా అదే చెప్తాను. ఇక్కడ opposing force link